We're going to do the double integral for this next problem in two different ways. We're going to integrate with respect to y first, then we're going to integrate with respect to x first. So take a look at this example. Find the volume of the solid that lies below the surface z equals x and above the region in the xy plane bounded by y equal 2 minus x, y equal x, and x equals 0. So we'll take a look at this problem. And so for our solution then, now I've already drawn the region in the xy plane. So this is the region in the xy plane. We were told the region's bounded by y equal 2 minus x, which is this line here, y equal x, and x equals 0. That would be this line over here. So the region over which we want to do the double integral is this region in here. If we integrate with respect to y first, the best way to visualize that is to draw arrows within our region in the positive y direction. And so in other words, have them go like this. And we'll put like arrows up here. And so in other words, notice I put the arrows within our region. You can put as many as you want, just enough to get an idea what's going on. Put your arrows in the region in the positive y direction. In other words, they're starting down here and pointing in the positive y direction. And then when you do this, your lower bound on your integral is going to be where the arrow starts, and the upper bound is going to be where the arrows end, where the head of the arrows are. So then let's set up our integral. We want the volume and put the double integral signs. And again, the integrand is going to be our z equals x. We'll put this here. And then we're integrating with respect to y first. So we'll put y dy, then dx, like this. And again, if you look down here, again, where do the arrows start? They start on the line y equal x. So we can write this up here. And then so the lower bound is where the arrows start. And the upper bound is where the arrows end. And they end at y equal 2 minus x. So once you put that inner bound in, then you just look to see, okay, where does everything project on the x-axis? In other words, you're just looking for what values are covered by a region on the x-axis. It looks like it's just covered from 0 to 1. So that's going to be x equals 0 to x equal 1, like that. Now, most people don't put the y equal and the x equal the way I do. So if you want to be more consistent with what the textbook use, then I'll just put x here, 2 minus x here, and 0 and 1, x dy dx. And again, remember, when you're using just this notation, you can tell that this is y equal x because this goes with the inner dy. So it's y equal x to y equal 2 minus x. And then for the outer one, it's x equals 0 to x equal 1. So let's go ahead and integrate this. And so again, we're integrating with respect to y first. That means we keep everything else constant. but we're going to integrate with respect to y. And so that's going to mean, so x is almost like a constant, so we're going to have x, y, dx, like this. And again, evaluated from x to 2 minus x. Then substitute your bounds. 2 minus x for the upper bound. We're substituting for y in that upper bound. Minus x times x like this. Dx. Again, all I did was put this in for y. Minus this in for y. And let's see if we can simplify this before we go ahead and integrate it again. So 0 to y. So this is going to be 2x minus x squared minus x squared dx. So this looks like that's going to be 0 to 1, 2x minus 2x squared dx. Now integrate with respect to x. 2x squared over 2, which is just going to be x squared. This is minus 2x cubed over 3. And that's just going to be x squared. Evaluate from 0 to 1. So we put 1 in here. That'd be 1 minus 2/3. And the upper bound is going to be that. Then the lower bound is going to be 0 minus 0. So it looks like the answer here is going to be simply 1/3, like that. So that's integrating with respect to y first, and then with respect to x. Now let's do this problem, except this time we're going to integrate with respect to x first. So what does that mean? So if we're going to integrate with respect to x first, inside the region over which we're integrating, remember this is going to be this region right here. We're going to put arrows in the positive x direction. And you really don't need too many, just enough to get an idea of what's going on. So we'll do something like this. And just like before, wherever the arrows start will be your lower bound. Wherever they end will be the upper bound. So let's go ahead and write down this integral. The volume. Double integral, we have x here, and we're going to do dx dy. We're going to do dx first this time. So one thing a little bit different, again, notice in this region down here, actually in all the regions, the arrows start at x equals 0. But notice what's a little bit different is that in this region, the arrows end on this line, and in this region, the arrows end on this line. So we're going to have two different upper bounds. So now, one thing we should do, we should change the equations of these lines so they're in terms of x equals something. So we can rewrite this one, of course, that's pretty easy. y equal x is the same as x equal y. Now up here, we're going to have to rewrite this one. That's going to be x equal, 2 minus y, like this. So we're going to have two integrals. So again, in this region, we started x equals 0 and ending at x equal y. And now then say to yourself, what region or what interval on the y-axis is covered here? And you can see it's covered from 0 to 1 for this first part. So for this first region here, y is covered from y equals 0 to y equal 1. But now we're going to need another integral for this upper region here, because again, the upper bound has changed. In this lower region, upper bound was this, but in this upper region here, the upper bound is x equal 2 minus y. So again, we're starting at x equals 0 to x equal 2 minus y, x dx dy. And again, we're going to have to see for this upper region up here, we have to see what values of y are covered. So if we look at this upper triangle, the values of y are covered from y equal 1 to y equal 2. Like this. And so now we have set up the integral. Not just a matter of doing the integration. Integrating with respect to x first. This is going to be x squared over 2 from x equals 0 to x equal y dy. Then on this one, again, it's going to be x squared over 2, but the bounds are from x equals 0 to x equal 2 minus y dy, like this. And put our bounds in. So up here, this is going to be y squared over 2 minus 0, so I can just leave that out. Upper bound here, this is going to be 2 minus y squared divided by 2 dy, like this. Then integrate again over here with respect to y this time. And that's going to be y cubed divided by 3. So that's going to be y to the 6th. Y equals 0. Y equal 1. Now over here, you could either multiply this out and integrate, or you could use u substitution. You can do it whichever way you're most comfortable with. If you use u substitution, yeah, it might be actually just slightly quicker to multiply it out. So I just went ahead and multiplied this out up here and got this. And let me just carry this left one down. And now let's integrate over here. Actually, 4 divided by 2 is going to be 2. Then we integrate, that'll be 2y. And this is going to be minus 2 y, but then we integrate it, it's going to be y squared divided by 2. So this one becomes y squared. So just notice that divide that was 2y. Then we integrate, that's going to be y squared divided by 2, comes out to be this. And this is going to be plus y cubed divided by 3, and then times the number that's down there. So it's going to be from y equal 1 to y equal 2, like this. And finally over here, we're going to get, when we put the 1 in here, that's going to be 1 cubed, which is going to be 1 plus, and then the lower bound 0 over here, we're going to have 2 times 2 minus 2 squared plus 2 cubed minus the lower bound is going to be 2 times 1 minus 1 squared plus 1/6, like this. And so let's take a look at this. 1/6. And actually notice this is going to be 4 minus 4, so those are going to cancel. And then this is going to be 2 to the third is going to be 8. That's going to be 8/6. And over here, this is going to be 2 minus 1. That'll give us 1. And then so it's going to be minus 1. And then minus a 6th, like this. And so we're going to have the 1/6 are going to cancel. And that's going to leave us 8/6 minus 1, which is going to be 2/6, which is 1/3. That's the same thing we got when we integrated with respect to y first. Now, this problem illustrates that sometimes there's a difference in steps if you integrate one way or the other. Notice when we integrated with respect to y, which we did first, we only had one integral, and the integral was pretty simple. We did with respect to x first, we ended up having two different integrals, and it took us a little bit longer. And it's usually more advantageous to integrate in the direction that just has one integral to set up rather than two. And again, that in this case, that was in the y direction. It was much easier to integrate in the y direction first. We got the same answer both times, but it was much easier to do y first.